Okay, we're back to look at part 2, focusing on sections 7 and 8 about our bonding. Most elements are going to follow our octet rule. Octet, remember we said, meant 8 full valence shell of electrons. Name one element that has a duet instead. That's going to be hydrogen. He'll want to only have 2. You could also go here after helium, lithium, beryllium, or boron. All of those are going to be ones that would go after a duet instead. Name an element that would have a full valence shell of 6 electrons. Here we're talking about PBS. Okay, those were our 3 exceptions we said that could violate the octet rule. The one that creates 3 bonds having a valence shell of 6 is going to be the B, boron. We said that when boron makes a structure, he doesn't have that extra valence pair, so he is going to be the trigonal planar, the flat molecule with the bonds at 120 degrees. The element that can form 5 bonds is going to be phosphorus. And we said that was the one that was trigonal bipyramidal. Where the bonds around the middle are 120 degrees and the bonds at the ends are 90 degrees. And the element that forms 6 bonds is going to be sulfur, and that's the one we said was octahedral, and the bond angle there is 90 degrees. Now remember, these only form these with hydrogen or any of the halogens. Okay, that's when they are exceptions. If we move on and talk about the interactions between molecules, we said that van der Waals forces was the weakest of our intermolecular forces. Dispersion was going to be the force between nonpolar molecules. And that's going to be the one that's caused by electron vibration. Vibration of electrons. Dipole is going to be the force between our polar molecules. And this is due to our difference in electronegativity. And then let's not forget hydrogen bonds. And hydrogen bonds are going to be between polar molecules with lone pair electrons and hydrogen. Okay, so please be sure that you're aware of dispersion, dipole, dispersion for nonpolar, dipole for polar, and then with some of your polar molecules, you're going to also have hydrogen bonding that occurs between those lone pair electrons and the hydrogens that are slightly positive. All right, let's talk about types of bonds. The type of bond that occurs between 2 nonmetal is going to be our covalent, where we're sharing electrons. Our crystal lattice structure is going to be between ions, charged particles. Cations that are surrounded by free-floating electrons, also known as our sea of electrons. Our 60s group, who wants to just chill together, is going to be metallic bonds. That's what allows for the conduction of your electricity as well as heat. Electrons are going to be shared in covalent bonds. We're going to have that electrostatic attraction where we really don't have a bond. They're just chilling together in our ionic compounds because we have the positive cation and the negative anion. Between the metal and the nonmetal is also ionics, because remember, our metal is our positive ion, the cation, and our nonmetal is going to be the negative ion, the anion. That's also the type of bond, ionic, where we have electrons being transferred, given away, not shared. Between two metals, we're going to have a metallic bond. What's an alloy? An alloy is going to be a mixture of two or more metals. And there's lots of examples you could use for the alloy. We talked about brass. We mentioned steel. Whoops, too many E's there in steel. So let's go back. Whoop. 14-karat gold, cast iron, stainless steel, okay? Okay, for number 12, we are going to be looking at the number of valence electrons that we have. And so we were going to switch over to a separate sheet of paper.